Okay guys, today is lesson 5.5. We're doing similar figures, and our learning objective is to determine whether figures are similar. And we are also going to be finding missing dimensions. So find missing dimensions in similar figures. In similar figures. Okay, so we have a couple of vocab terms we need to talk about before we can even determine whether figures are similar. So in math, similar, we're going to be talking about figures that are the same shape. With the same shape, but are not necessarily the same size. And I'll explain what I mean by that. But are not necessarily the same size. And then we're also going to be looking at congruent angles, which is a review. We've talked about congruent angles a couple of lessons so far, but congruent angles are angles that have equal measures. And when we talk about similar figures have to have congruent angles. So I'm going to write a little note here. Have to have congruent angles. Figures cannot be congruent if their angle measures aren't the same or if they don't have corresponding angles. Okay, so we're going to do an example 1. We're going to look at which rectangles are similar. Okay, so we've got rectangle J, we've got rectangle K, and rectangle L. So first we're going to look at the corresponding angles and are they congruent? Well, they're all rectangles and all of the rectangles have 90-degree angles, so yes, they are congruent. They're all the same. It says all the angles of rectangles have a measure of 90 degrees. So we're going to compare the ratios of the corresponding sides in rectangles J, K, and L to see if they're actually equivalent. So for J, we've got this long side here, and that's 10 centimeters, and then the shorter side, that's 4 centimeters. So looking in rectangle K, the longer one goes on top. This matters. That's just like proportions from yesterday. The same thing goes on top as the bottom. So corresponding here would be the longer side, 5 and then 2. And then the longer side here, 12 and 5. Okay, so just like with our proportions, we're going to use cross multiplication. Cross multiply to see if they are equivalent. So I'm going to compare J and K first. So I've got 10 over 4. We're seeing if it's equivalent to 5 over 2. Cross multiply, that's 20 and 20. So those two are similar rectangles. And let's check if the other ones are similar. So I'm going to compare J and L. So J is 10 over 4. L is 12 over 5. So cross multiply, that would be 48, and that's 50. So those are not similar. They do not give us the same number there when we cross multiply. And let's check the last one, which I already know aren't similar because if they were, J and L would be, but we'll check. So K and L, we have 5 over 2 and 12 over 5. So cross multiply, I've got 24 over 25. These are not similar. So the only two that are similar are rectangle J and rectangle K. Again, using those proportions that we learned in lesson 5.5. Okay, so going to example 2, we kind of have the same question. Are any of these triangles similar? So we've got triangle QRS here, and R has that right angle. Okay, we've got 60 degrees for Q and 30 degrees for S. Here we've got triangle TWV. We've got a right angle here for W, but this angle is 45 and this angle is 45. So already I know these two are not similar because they don't have the same angle measures. But we can still check with cross multiplication. But already I know they're not similar. Okay, here with this triangle, I've got triangle X, Z, Y. Z being that 90-degree angle, then I've got 60 degrees, and I've got 30 degrees. Noticing that my first one, QRS, had 60 and 30 as well. 60, 90, and 30 as well. So these two could possibly be similar triangles. Okay, so let's set up a proportion to see if they are. So I'm just going to use this side RS, which is 10.4 over side RQ, which is 6 feet. Okay, and I'm going to compare it to kind of using that same vantage point. This is the 90-degree angle is Z, so I'm going to do, and it has to be this way. ZY is the longer side, and that's 5.2, and I'm going to compare it with ZX, which is 3 feet. Whoa. Which is 3. Making sure I use those corresponding sides that we talked about earlier. Notice how my R started with 90, so I did the longer side, that's the 10.4, longer side, that's the 5.2. Then I did the shorter side here, and the shorter side here. Okay, I could have chosen any other side, but that's just what I chose to use. Okay, so we're going to set up a proportion to see if they are equivalent. So 6 equals 5.2 times 3. Cross multiplying. I'll have enough room that way. So on this side, I have 10.4 times 3, which is 31.2. And then I have 6 times 5.2, which is 31.2. So those are similar triangles, although their side lengths are different, but proportionally they are similar. And their angles are identical, which has to happen. Okay, now a little side note. Do a little side note here. Okay, if I tried to see if they were congruent with this triangle, TWV, I could set up those two sides. So I've got 10.4 over 6 equals 6 over 6. And multiplying, that gives me 36. And then 10.4 times 6. That gives me 62.4. So I know for sure those are not similar. If the angles didn't prove to me that they weren't similar, then the proportion will as well. Okay, so we've got two word problems here where you're going to have to draw triangles to kind of visually see what we're doing. So we've got a t-shirt design that includes an isosceles triangle. So we know we're dealing with an isosceles triangle, which means 2 of the sides are the same and 2 of the angles are the same. Okay, and it says the side lengths are 4.5 inches, 4.5 inches, and 6 inches. Okay, and then it says an advertisement shows an enlarged version of the triangle with 2 sides that are each 3 feet long. So kind of a greater triangle with sides that are 3 feet. Notice the difference in dimensions there, feet and inches. And then it says, what is the length of the third side? So we know this is 3 feet, but we don't know X, which is that third side. So first thing, we need to have like the same thing that we're comparing. We have the same units. So if we're looking at the smaller one in inches, let's look at the larger one in inches. So 3 feet, we know there's 12 inches in 1 foot, right? So 3 feet times 12, that gives us 36. So this is 36 inches. 36 inches. So setting up a proportion, we've got in the smaller one a side that's 4.5 inches and a side that's 6 inches. Noticing how it's the bottom there. Okay, now using the same corresponding sides in the larger triangle, we're going to set up this side, this diagonal side, which is 36 inches, and then this bottom one, which we don't know, is x. And so this is where we're going to be solving equations using that cross multiplication. So first, we've got 6 times 36, which is 200, we'll write it. 6 times 36, and then we've got 4.5 times x, which is just 4.5x. So now we can do that 6 times 36, which is 216 equaling 4.5x. This is something that we've done since the beginning of the year. We got to solve for x, get that x by itself. So we're going to do the opposite and divide by 4.5, divide by 4.5. Use those calculators. That leaves us with 48 equals x. So this was in inches. So 48 inches would be the measurement of x, but they gave it to us originally in feet. So we're going to have to convert it back. So we would do 48 divided by 12, which is 4 feet. So that third side is 4 feet. Okay, so the next one, we have a flag in the shape of an isosceles triangle. So we got that isosceles triangle again. We're going to draw it. With side lengths of 18 feet, and then 24 feet. Okay, it's hanging on a pole outside of a campground. The camp t-shirt shows a smaller version of the triangle with two sides that are 4 inches long. Okay, so smaller that are 4 inches, and we need to know the length of the third side. So first, we need to be dealing with the same units. Again, we have feet and inches, so we need to convert them to be the same. Okay, so let's turn these feet into inches. So we need to take 18 and multiply it by 12 to give us 216. So I know this side is 216, and then 24 times 12 inches gives us 288. So 288 down here. Okay, so now I can look at my corresponding sides. So I'm going to use the same ones I did above. I've got this is 216, setting up a proportion. 216 in the same triangle, this bottom one is 288, equaling, 4 here, and then x. So again, using that cross multiplication, we've got 216 times x, and then we've got, I don't have enough room. I'll write it down here. 216 times x, and then 288 times 4. So that leaves us with 216x equaling 1,152. And then we need to solve for x. Again, you've been doing this since the beginning of the year. I'm going to divide by 216. Divide by 216. That goes away. I'm left with, divide by 216. I'm left with, let me check to make sure that's right. 1152 divided by 216. Yep. So I've got 5.33. So that x is going to be 5.33 inches. And we don't need to convert that back because that's what our triangle is in. Okay, so you should move on to practice C this time. My answer key will be on the link.